Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at lesson 7.8, factoring by grouping, and we're going to be looking for 6 things in our notes. Let's go ahead and get started. First thing we want to know is how to do this factoring by grouping, which basically means when you have a polynomial with 4 terms, and really we're going to be seeing just 4 terms with polynomials. So the first thing you want to do is group terms into pairs. You want to make sure that they have something in common. And what that means is they should have either a common factor of the coefficient or a common factor of the variable, and we'll look at more of what that means in just a moment. The next thing we want to do is factor out that GCF of each pair of terms. Once you have that GCF factored out, you're going to notice that there's a common binomial factor, and that is going to be one portion of your factoring. The other portion will be what you factored out. So they're pretty simple steps. They might not make a lot of sense right now, but we'll get to try some here in a few moments. Let's go ahead and take time now to pause the video here so you can write down your 3 steps of how to factor by grouping, and then once you're done, click play so you can see how it is done. So this first one, we're just going to practice factoring by grouping. One thing we notice is most of the time the polynomial is going to be written in the order that you want it in to group it. In this case, I'm going to be grouping these first 2 to make this binomial, and these second 2 sets to make the second binomial. Sometimes you might have to mix some stuff around, but that's okay. The reason why I grouped x to the 3rd power together is because, and 3x to the squared, is because they both have x to the 2nd power in common. So what I'm going to do is just go ahead and factor out x to the 2nd power out of each of these. X to the 3rd divided by x to the 2nd would be x, and 3x to the 2nd divided by x to the 2nd would be 3. So my first group would be x squared and then parentheses x plus 3. Remember, another way you can check this is to redistribute. Then I move on to my next one. 2x and 6 do have something in common. They both have the number 2. So I'm going to write plus because we're separating ourselves with a plus sign, and it's a positive 2 that you're also factoring out. And then what I'm going to do is just go ahead and divide both of these by 2. 2x divided by 2 is x, and 6 divided by 2 is 3. Notice we have a common binomial, and that's going to be part 1 of our answer. So because we have x plus 3 together, we can write that down as part of our answer. The other part of our answer is what we factored out. I'm going to change my color here so you can see what I'm looking at. This x squared and this 2 are my GCFs. So these are going to go in the second binomial. So I'll just have x squared plus 2 because that 2 is a positive. So my answer would be x plus 3 in parentheses, and then timesing that by x squared plus 2. If I refactored all of this, or if I FOILed this, I would end up right back where I started with that polynomial. So this would be how I would answer factoring by grouping. So here's one that you get to try. Again, you might need to switch some stuff around to make sure that they have something in common. Once you find the 2 pairs that have something in common, go ahead and factor out that common factor, the greatest one, and then try to figure out what your binomials will look like. Let's go ahead and pause the video here so you could try it by yourself. And once you're done, click play to check your work. Okay, so what I did for this one is I rewrote them in the order that I wanted them so that the common terms would be close together. So I put x squared plus x because they have an x in common, and then I did y plus xy together. If you maybe even switched around the y's and xy or the x squared and x, that's fine, just as long as they are going to be grouped together. So I'm going to group my first 2 together, which would be this x squared plus x, and then the y and x plus y would be also grouped together. The first set, x squared plus x, has an x in common. They both can be divided by x. That's the greatest common factor. X squared divided by x is just x, and x divided by x is 1. Then I'm going to come over here. My common factor between y and xy is going to be y. So if I divide both of these by y, I'm going to get 1 y divided by y, and then xy divided by y is just going to give me x. Now notice these are switched around, these binomials, but they both are representing a positive x and a positive 1. So I'm going to just rewrite them as my first binomial, x plus 1, and then bring in my two common factors, x and a plus y. So my answer would be parentheses x plus 1, parentheses, and then parentheses again, x plus y. Here's another one we're going to try. Again, pair them so that they have a greatest common factor in common. And then once you're done, click play to check your work. All right, so what we noticed here is we have some a's and we have some 3's. So what I did is I rewrote it so that I have a to the third plus a together, and then 3a to the second plus 3 together. The reason why I put the a's together is because they have an a in common, and the reason why I put the 3's together is because they have a 3 in common. So what I'm going to do is factor out an a first in the first binomial. A to the third divided by a is a to the second, and a divided by a is 1. Then over here I have a 3 in common, so I'm going to divide out the 3's. 3a squared divided by 3 is just a squared, and 3 divided by 3 is 1. Noticing when you factor out correctly, you will have this matching binomial. If you don't factor out correctly or you don't use the greatest common factor, you will not have a matching binomial, so there's something else that you did wrong. Now that I have a squared plus 1, that's going to be my first binomial of my answer. And then my second binomial will be a plus 3, because I'm just using, again, my two factors. Okay. Again, here's one we can try. This one now has more numbers written with it. Do be careful with your positives and negatives. You're going to make sure that you factor the polynomial completely by grouping. So make sure you look for that GCF in each one. Let's go ahead and pause here. This one you may be factoring out a number and a variable, so just be careful. All right, so you should have noticed first off that 3 and 24 have something in common. They also have a variable in common. The same thing is true with 5x and minus 40. They also have a number in common. I'm going to start here with my first one. 3x to the third and negative 24x to the second have a 3 in common as well as an x squared in common. I am going to try to use as much x's as I can, like we did before in the previous video on factoring, to make sure that I'm factoring all the way down. 3x to the third, I'm going to go and write down what I'm factoring first. 3x to the third divided by 3x to the squared is just going to give me x. 3's divided by 3's, x cubed minus x squared. And then the next one, minus 24x squared divided by 3x squared is just going to give me minus 8. Okay. For the second binomial, I'm going to be factoring out a 5 because 5x and negative 40 both have 5 in common. Notice that I'm factoring out a positive 5, so I'm still going to write plus 5. 5x divided by 5 is just x, and minus 40 divided by 5 is minus 8. Notice that my two binomials are matching here, so that means I factored correctly. So I'm going to have x minus 8 as one binomial, and then 3x squared plus 5 as my second binomial. Again, here's another one, making sure that you're factoring out correctly with your problems. Let's go ahead and pause here, try it, and then click play when you're ready to check. All right, so my first two, 8n to the third and 8n to the second, have 8n to the second in common. So let's go ahead and factor that out. 8n to the third divided by 8n to the second, write that down, is n. And then 8n to the second divided by 8n to the second is 1. Noticing that there's a minus sign, so I'm going to keep the minus sign. Now, if I factor this correctly, my second binomial should also be n minus 1. 7n and 7 both have 7 in common. So what I'm going to do is I'm still going to keep this minus here. Minus, and then I'm factoring out a 7. 7n divided by 7 is n. And then keeping that in mind, 7 divided by 7 is 1. But since I'm distributing this negative, you see how I brought down my negative? This should also be a negative. And I want to keep it the same as my other binomial. So my first binomial is n minus 1. And my second binomial is 8n squared minus 7. So make sure that you have your positives and negatives correct there. The last one we're going to look at, let's go ahead and again factor by grouping. Factor all the way down as much as you can. Let's go ahead and pause here, and then we'll check it once you're done. Okay, so the first one, I saw that I had a 24x cubed and a 20x squared. Those do have something in common. They have a 4x squared in common. So I'm going to divide both of these by 4x squared. 24x cubed divided by 4x squared. 24 divided by 4 is 6, and x cubed divided by x squared is x. Negative 20x squared divided by 4x squared. Negative 20 divided by 4 is negative 5, and x squared divided by x squared just cancels out. So my first binomial is 6x minus 5, which means I should also get that same binomial if I factor out correctly for the second one. 30x and negative 25 have a 5 in common, so let's go ahead and do that there. 30x divided by 5 would be 6, and keep the x. Negative 25 divided by 5 is a negative 5. So now that I have my two common binomials, I'm going to first write down 6x minus 5, and then my second binomial will be 4x squared plus 5. Okay, so there it is. That is going to be the conclusion of our notes today. Thanks so much for tuning in, and we'll catch you next time. Bye.